Welcome, everybody, to the Chia Developer Roundtable with a focus on Mempool Parallelism. We've also called this the concurrency contention. The core issue we're going to describe today and discuss is within the Chia coin set model and in blocks, you have coins that are spent. This leads to an issue where if you have multiple things that need to be spent against one coin, such as an AMM setting prices for people buying via offer files, or votes that need to go again into a single block in order to count and tally up those votes, you need the opportunity to spend a particular coin, or in some cases a singleton, more than once. And that is kind of that parallelism or that concurrency contention that we're going to be discussing. Today's event is a little different than the ones we've held recently. This is going to be a developer roundtable with the panelists that you see up here. We have Bram and Brandon, or Rigidity as you know him, from Chia. We also have Yak, very well known for his AMM, Tibet Swap. And we have Michael Taylor, which I'm sure everybody knows from the Dig network. If you do have questions throughout our event, please use the Zoom Q&A. We are going to do our best to capture questions on YouTube, as well as inside of our community feedback channel on Discord. That being said, let's go ahead and talk about some of the use cases that run into this issue of mempool parallelism. Michael Taylor, I believe this conversation started with you in one of your Twitter posts, so I'm going to turn it over to you and put you in the hot seat. Do you mind describing some of the use cases you've seen that run into this issue?
Sure. I noticed, in a general sense, when we're trying to build applications on top of Chia, we inevitably end up into a situation where we need to hold a state on chain, and one of the big use
Can you give an
cases.
example? Yes. Can you give us
Yeah,
a
yes.
concrete example?
One of the big examples, use cases that I'm currently working on that's near and dear to my heart is a ballot box scenario. Basically, DAO type functionality. Um, we the ballot box ultimately needs to be the aggregate of all the votes that people are voting on, and you can't really spread out the votes across multiple coins and still be able to operate on those votes within Chia lists. Eventually, one way or another, it needs to be rolled up into a single state coin, or AKA the ballot box, in order to actually operate on the final result. In the current paradigm, there's major challenges trying to aggregate those votes, as typically you can only spend in order to count the vote, you have to spend a singleton. Singleton can only be spent one time per block. And you end up with a throttle at scale where if you have a bunch of people trying to vote all at the same time, they just have to wait until the singleton's ready to go, ready to be spent again. And you have a lot of people stepping on each other's toes. And we actually saw that in a different use case with the Dig rewards distributor when we were staking the data layer minions NFTs in our puzzles, because in order to stake the NFTs, we had to spend that singleton. And when it was first announced, we had a mad rush in order to stake, and people just couldn't get through. And it just creates a major bottleneck. So the first time I ran across this was in that staking system that Yak and I put together. And right now, what I'm trying to figure out is how to vote at scale on Chia.
Yeah, thank you very much. Yak, I'm going to turn it over to you because you also have a different use case that relies on AMMs, coin prices, and then of course you've seen this a little bit with the action layer you're building.
Yeah, so to go a bit back to the problem statement, if you think of really any decentralized apps, what they have is some kind of shared state, and then anyone can interact with the decentralized app through a set of defined actions. So the problem is, how do you get multiple people to act on the state, and how do you order those? So what happens with Tibet swap, as Michael mentioned, by default, you start with a throughput of 1 transaction per second. What you can do is use this mechanism replaced by fee. That wasn't really designed for this functionality, but you can use it in a way to spend a singleton maybe up to 6 times per block. And that has so far worked okay. But as users increase on Chia, I expect people to want to transact with an AMM pair more than once every 10 seconds. The action layer is kind of a primitive that abstracts all that. There's a state and multiple.
Before we get into that, do you have other use cases that you care about?
Yes. So currently, the bridge and Tibet swap are using RBF. At least Tibet swap has an announced new version, and it would be nice.
What is that as a use case? What is the bridge doing?
People interact with it to relay messages. And you need messages to be relayed by a singleton so you can later authorize them.
Okay, so you have... okay, I have to ask, how does a message relay work? How do you get the thing to give a message?
Yeah, generally you consider a message valid if it's produced by the bridge singleton, and then that singleton can have a custom logic. So for example, right now it's a multisig made from the validators. It's a multisig controlled by the validators hotkeys, and when you collect 7 of them, you can then spend the bridge to create the message.
Oh, I see. So it's not that the validators... Okay. The validators don't spend the coin themselves. The validators sign things, and then you can make the message get broadcast.
Exactly.
Okay, so you have this singleton that you say, hey, here's a signature of a thing, therefore you should make this announcement or send this message, right? And it does that. And you want to be able to do multiple ones of these per block.
Yes.
Okay, so all right, that's another thing that one might want to aggregate. Got it.
And I would add, in general, it would be nice to have something a bit more flexible, such as being able to just aggregate the action layer, so people could just build puzzles with these pieces, and then they know it's
I want to talk
it can be aggregated.
Okay, I want to talk about use cases first before solutions. So, okay, I do have to ask though, what's the anti-replay on this? Because someone could just, once you have a message or once you have an announcement that the relay is supposed to make, couldn't any Yabo just keep refeeding that in and spending it to make that announcement over and over again?
The signature depends on the coin ID, and every time you create a message announcement, you basically embed the message ID into the puzzle hash. So the validators know not to emit a new signature for a message that has been relayed.
Okay, so you're doing not effectively, you're doing not an announcement, you're doing a message to a particular coin ID, and that coin ID, the anti-replay.
The singleton ID, the portal singleton coin ID.
It's based off the exact coin ID right now. Okay, got it.
Yes, but to add, in the solution, you can specify multiple messages to relay, and you can relay all of them with the spend. It's just more of a coordination problem.
Depending on what exactly you're doing, it might make sense to well, those things should be messages rather than announcements anyway, but we could make it so that the anti-replay was based off of the coin ID that the message was going to. That would be convenient, because that would give you greater flexibility. That way you could kind of at your leisure collect these things to authorize a message to be sent, and even if you took some time to collect them all and other announcements had been made in the interim, you could still successfully get the message really.
I think it's that the message already has an ID from the other side, from the side that produces it, but the recipient is a puzzle hash, not necessarily a coin ID.
Okay, all right. Okay, all right. Anyway, there's a few variants on this that could happen, but all right. Um, yeah. Um,
Yeah, thank you. So we've discussed a couple of use cases,
I
and
have a use case
yeah,
as well. Okay, so my use case is I want to support concurrent AMMs. I actually really don't care about supporting reordering AMMs. I don't really want to have AMMs where multiple people want to spend the same AMM in the same block. And so then you kind of come up with some order of those transactions that happen and make those all go through in the same block because that gets you back to MEV. And that's exactly what I don't want to do. I would like to support AMMs where a whole bunch of people want to place orders with the AMM and those get smashed into a single AMM spend with a single set of AMM prices, the way the aggregation works. Um, so yeah, that's a thing. Um, the um, yeah, and things I'm less concerned about are like having limit orders for an AMM because there's this question of if someone has a way out of the money offer to an AMM, is that worth propagating? And how close to the money should it be, and blah, 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 for it to be worth propagating in the mempool. And in some level, I don't really care. Like the very, very basic AMM things are you tell the AMM, here, I am sending you this amount of this thing, and I want my change back again to be denominated in this other thing. Give me my stuff back. And it just gives you back whatever based on what the current price is. And that's just the way it works. Um, so yeah, those are the semantics I'm interested in supporting, or at least having a plan for in the future.
yeah, thank you very much. So we've heard a few different use
Hey,
cases.
yeah, hey, Brandon, do you have a use case you want to whine about?
Exactly.
Yeah, I mean, I'm building a primitive for auctioning NFTs, and it would be nice to have the ability to spend that singleton more than once per block. I guess that just kind of goes into the same.
Yeah, what does that do? What do you mean? What's the semantics of this thing?
Well, it's just that in the general case, with the action layer, you want to be able to include more than one action per block.
No,
Uh,
but what are the actions? What is this thing doing?
in this case, it's just either bidding or ending the auction. I suppose in this case, you would want to automatically remove inferior bids and replace them with better bids rather than including them both.
Yeah, that's really interesting. I think it might be a lot easier to make it so that when someone makes a bid, they've just made the bid. They don't conveniently get their thing removed from the mempool, so they're still paying for their transaction. They just don't get in when it gets aggregated. Might be the way to go with that. Um, okay. Cool. All right. So we got message relay. We got uh, votes. We got auctions, and we got AMS.
And I think generally we want to be able to support anything that an Ethereum smart contract could do.
Yes. Well, I think all the stuff that we just said can be done with concurrent, with aggregations that become concurrent. So that instead of saying, well, here's a bunch of spend, like the thing we have right now actually orders stuff, but that's because it's stupid in a very narrow way. So, the thing we have right now only works when a particular puzzle hash literally doesn't change across all these multiple spins that are happening, and then it sequences them one after another. So that's doing something. It is vaguely general, and it's not too hard to support, except it's totally blown up in our face once already. So we're very leery of adding new functionality as a result of that. But I believe all the things we were discussing here don't require this functionality of it being a bunch of individual transactions that happen in a row. That it all these things, it would be totally reasonable if the way you aggregated transactions was to a single spend of the singleton that happens right now.
I
instead of
get,
an ordered series of spends.
well, it depends on what we're defining ordering a spend as, because in this case, you are ordering action spends within a single coin spend, but you're not creating multiple ordered coin spend.
Right. The difference being that if if you give all the spends to the singleton as a list, right? Because it's being given it as a list, the coin puzzle can be smart enough that it has semantics that don't rely on what that order is or don't rely on it very much, right? So it can be clever about saying, okay, here's all the like AMM actions, and I'm just going to assume they're all happening simultaneously, right? And like if you're doing an auction, it's just like, well, I'm going to reset it so that the person who's in the lead is the current highest bidder, and that doesn't rely on the order. And if you're doing voting, then you just have a cumulative sum to all of them, and that's concurrent. And if you have message relay, you just do all the announcements, right? So all of these things don't need to support semantics of any coin getting spent repeatedly. Like it's totally reasonable for all of them for it to be a single aggregation that happens.
Yep. But under the hood, you still have state that's changing between each spend.
Huh?
Under the hood, you still have state that's changing between each execution of an action in the same block.
So, so my thinking is that it's up to you have a particular puzzle that you're okay with for whatever reason supporting aggregations on this puzzle, right? We need some reasoning behind that because there's all manner of DOS potential issues here, right? If you have some puzzle that engages in really bizarre behavior where its costs can fling around and its behavior can fling around in crazy ways, that its behavior is not very commutative and like adding transactions can cause the overall costs to jump up or down in weird ways, that can create all kinds of problems if you support aggregations of poorly behaved puzzles. But if you have a well-behaved puzzle, for the most part, the aggregate cost of a bunch of things is going to equal the sum of their individual costs, roughly speaking, not too far off, presumably. Um, it is my thought is instead of having a particular piece of code that we say this is the thing that has like states between stuff, we just say we're going to decide some puzzles are okay via whatever mechanism, maybe just whitelisting them. Um, and those puzzles are responsible for enforcing their own semantics, for making sure that they themselves are well behaved.
It's kind of like what we did with fast forward, and we had special case the singleton puzzle because we knew certain invariants about spending it.
Yeah, we know how to manage that thing. It's actually it's potentially easier if you don't need to worry about if the mempool doesn't need to know how to do aggregations and the individual puzzle is responsible for figuring that out. But there's massive gotchas here, mostly having to do with cats, actually. So, like in the case of an AMM, right? You would say all your individual spends, right, to this AMM. Say, okay, here we go. I'm making a spend and I'm sending it to you, the AMM, right? So the singleton is the AMM, and everyone has a spend or multiple spends that say, okay, here, I'm spending this thing, I'm demonstrating them spending this thing, and I'm sending it to you, the AMM, and you should give me change, right? And here's the denomination I want my change back in. And so they do not produce their own change, right? That when they're making these offers, these like partial things to the AMM, in each of their individual things, the returns are always coming back from the AMM itself. They don't create their own rewards. Um, They just tell the AMM, here's what I'm giving you, and then the AMM calculates what it's giving back, because that makes aggregation way, way easier. The AMM kind of calculates that after the fact and then just gives them back whatever. So that, in some sense, makes aggregation easy. If you're the mempool, right? This is the mempool implementation. It just knows it needs to take the lists of solutions in these individual transactions it has and just like concatenate them into a longer list and just pass that to this trusted puzzle that it knows aggregates things reasonably, and that'll do whatever it feels like doing after the fact, after it's given these things. There's a list of problems with, so this works great, and can be made into like a nice concurrent AMM that has no ordering within the transactions in a single block, which is really, really nice to have. The problem, the problems with this all center around cats. So two things. Number one, the AMM actually kind of needs to be two coins, right? At least, because it is covering two different transaction types. It's like Chia and like Spacecoin, right? We're doing an AMM between Chia and Spacecoin, right? And these kind of need to travel together. That the reserve of Chia that's held within the AMM can be held within the main AMM coin, but it needs to be cooperating with this other coin that's a Spacecoin coin, because that needs to be a cat. So those always need to be spent together. So it's not like the AMM coin can just finish and do whatever it's doing last, because it needs to send a message to its Spacecoin coin for what it should do, and that does the final thing. So it's not like you take all these solutions and hand them to the AMM and it just decides to do whatever it feels like doing. It then has this dependency where it sends a message to the Spacecoin coin, and then that one does a thing afterwards. And the logical flow needs to happen in that direction. So that needs to be supported. Then there's this other problem that to do this elegantly, the mempool needs to be able to do the cat aggregations, right? That this generated a series of things where cats were sent around. And now the mempool has these transactions that aren't really valid because it needs to do the cat chaining loop thing to make these be valid cat spends. And that does mutate their solutions. Cat solutions are intentionally mutable to allow this to happen. But now the mempool needs to be smart and be able to take these things that should add up nicely, but it needs to be able to finish doing the cat aggregations on them to make them work. So in order to support concurrent AMMs, that's the extra functionality that needs to happen there. So and I'm not sure the best ways of doing all of that. And in particular, I'm really not sure what the right heuristic should be for deciding when a particular coin has aggregatable solutions, both whether it supports aggregatable solutions at all, and whether we trust that particular thing to have aggregatable solutions well enough that we're okay with keeping it our mempool and then relaying that around to others who might also trust it. The obvious way is we just have a whitelist. We say, well, if we have something that is like a singleton that has like curried in data that can be whatever, but the thing it's curried into has this hash, then that's whitelisted. That's a thing that can be done. And it would be pretty easy to make a decent length list of those. But that's also has this weirdness that it's kind of bespoke, and anyone who wants to do anything new needs to go around campaigning for enough people to add it to their mempool stuff for it to get in. So that introduces interesting headaches. It would be nice to have something where there was something a little more general, but I don't know how to I don't know how to make it reasonably general. I mean, we could make it so that the whitelisted things are somewhat parameterized so that more stuff could be done there. But you definitely run into these issues where if you're willing to aggregate whatever, a malicious person can introduce a whole lot of things that don't behave properly when aggregating and get all kinds of crazy things getting kicked out of the mempool and costs going all over the place and crap like that. All right, that was me monologuing for a while. So
No, thank you very much. I think what we've done, I'm going to just recap and summarize for us real quick here. And for those just joining, if you do have questions, please use the Zoom Q&A, send them in YouTube or in our community feedback Discord channel. We're discussing mempool parallelism, the issue of being able to spend a coin multiple times within a block. And some of the use cases for that are AMMs, voting, and we also have discussed message relays, such as like what the bridge does for us. The current workarounds we've already discussed are RBF, the replace by fee, as well as the fast forward, which is being used for vaults and allows a singleton to be spent multiple times. The limitations that arises when you do, either RBF or you're using fast forward, RBF has the limitation of continually increasing cost. The fast forward is effectively a constrained operations setup, which limits limits what can be done to puzzles that are already known and how they operate. And some of the other things that we have already started to discuss are the challenges, which are that complexity, the additional security, such as DOS vectors or the replay attacks, the leaning over to a MEV world like you have in Ethereum. And we've also talked about the mempool adoption issue, which Bram just raised, where if you do constrain it to particular operations, you have to make sure that those operations are adopted by the mempools. After that recap, Yak, I know you have your hand up and you are deep into the AMM world.
Hold on though, but on that recap you did, I want to pedantically knit that I very specifically just went on a tirade about how I don't want to spend the same thing multiple times in a block. I wanted a single thing to do an aggregated spend in a block.
Yes, thank you. Thank you. I appreciate the clarification.
I think part of the confusion is that the term spend is being used for both coin spends, but also interpuzzle spends within a single coin spend.
Uh, yes, but also that there is definitely a difference between a bunch of things happened and there was an order to them and state between it, and it was a single aggregated thing. Like this becomes very, very obvious with AMMs. There's a huge difference there.
So I was actually wondering about AMMs.
Yeah.
If you do everything at the same time, then you basically have no way of knowing the execution price when you submit the order.
Well, I mean, you have that anyway. You don't know where everything is going to have moved to by the time you do your thing. This is the way AMMs work in general, right? That you tell them, or at least the way the original Uniswap worked. Now they have limit orders and stuff. But you tell it, here, I am sending you money, and I want you to send me back money. But I'm not telling you the exchange rate. I'm just trusting you to give me a good exchange rate, whatever that is. And the AMM does that for you. And when you limit your semantics to those, it means that you don't have to niggle so much about, is this transaction going to go bad before I send it? If you have a limit order, now you have a problem, because if you're the mempool, you go, well, this isn't valid right now because it's not hitting, right? So do I propagate this or not? And even if you are willing to propagate things that are within their limit, you might have this really annoying thing happen where you incur quite a few costs for propagating a whole lot of things that are within limit. And then the limit just moves a tiny little bit and none of them get through. And you just wasted all this like resources propagating things in the mempool that don't make it in. And maybe somebody like forced a whole lot of other things to get cleared out of the mempool maliciously in the process of this happening. So there's a lot of practical benefit to not supporting limit orders.
But then this kind of allows slippage, which is, after all, the cause of MEV. Because the way Tibet Swap works right now is you upload an offer because you know the exact price, and then the AMM accepts that offer. So if you let multiple people kind of bid one after another, they'll know the exact price.
So there's this, right. So what happens is, it's easy enough to support basic limit offers where you say, I'm putting this in and it's going to fail if the price goes more than this amount. Oh, you know what you could do? You could do what we were just discussing for auctions, actually. Somebody submits a limit order and they say, here's what I want to do. I want to send you this money and I want to get it back in this other thing, but not if the exchange rate is worse than blah, right? You need to give me at least this amount, right? But then what should happen in order to prevent weird DOS stuff, you'd want to make it so that the transaction still gets in, it just doesn't do anything. That the AMM looks at it and goes, well, that didn't make it in, and just skips it and goes on. And so you got dinged for the transaction fee for it happening because you had to pay to have your transaction propagated, right? Um, but uh, but it's still uh, 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 but it still had the semantics that you wanted, that it didn't go if it didn't hit a certain price.
But then you'd pay for an order that didn't get filled at all.
Yes, well, you're using the mempool, so if you want to get anywhere in the mempool, you have to pay for propagation through the mempool. Those are the rules.
Thank you. Michael Taylor, I see your hand up. I'm going to turn it over to you here.
Sure. So the thing that I was really interested in exploring and what kind of prompted the original tweet that kind of ended up in this roundtable was I'm really interested in the features of chip 50, the action layer. And forgive me if I butcher this explanation because Yak's the one that wrote it and he can explain it better than I ever can. But my understanding of it is he essentially created like a type of roll up system within a spend bundle. You can actually like create multiple actions for a singleton within a spend bundle instead of doing it in parallel, instead of doing it in serial one block at a time. And then there's a finalizer that kind of just rolls up the aggregate of all that and then finalizes it into the state of the singleton. And it's super interesting in that it's in the direction of what would be needed in the types of applications that I'm looking at. The limitations are that if you want to do it like outside of a single spend bundle, you want multiple people to contribute actions to that finalizer. The only option at the moment is like RBF, which yeah, Yak has expressed to me like after about 6 RBFs, you're effectively priced out, and it just doesn't scale.
Yeah. Yeah, what you want to have is something where the mempool is a little bit smart, right? So what you want to have is the mempool is taking in these transactions, and there's multiple transactions that spend the same coin, and the mempool goes, well, that's okay because I can aggregate these, right?
Yeah. So I was very interested if there was any path forward or appetite to explore taking the concept of the action layer and expanding that mempool wide. And I think you probably have better ideas on how that would work since this is your system. So I don't want to talk for you, but I think that's what I was really interested in exploring when I kind of like went on to some Twitter rant like about mempool.
No, thank you for bringing that up. So I think generally for the action layer plus a certain finalizer, because the finalizers are going to do their thing. Like there's a finalizer that, for example, talks to a reserve cat for singletons that will hold appellants.
Yeah.
I think you could do some more general logic.
Well, see, what
But
I
I
was
still think
so from what I was saying, I think it's kind of has the same concepts. It's just that the aggregation algorithm is always just these things that you do aggregation on. Always just take a list of mini solutions, and the aggregation is always you just concatenate the lists. And then the finalizer is the puzzle. It does something. So that can vary between puzzles. It's just a question of which ones are you okay with doing this for.
I still think to have an efficient mempool, you need to customize for a given app. For example, this is an AMM, and that's how. So that's why I was kind of proposing private, like app-specific mempools that just have all this logic in them, and they produce a final bundle that kind of maximizes the
Uh,
fee.
so I think we can set something up where the only distinction is what puzzles are whitelisted. So it's a normal mempool, right? We have some kind of aggregation logic that's shared across everything. And when you talk about an app-specific mempool, it's not really the mempool being different. It's just there's some fraction of the entire mempool that's okay with the particular logic of this particular thing.
I would categorize it more as domain-specific mempool over app-specific. I think that make at least jives in my mental model a
There's
little.
a
The logic for aggregation changes depending on which kinds of coins you're aggregating and which puzzles they have. Like for example,
but
for
the
handles, the slot primitive has a solution that needs to be modified per spend when
yeah, the thing is the puzzle itself can do the aggregation. You give it you give it the list of many solutions. It does its own finalization, aggregation, everything. It decides how these are all combined together and what to do with them. So the only thing that's special, I hope we can make it so that the logic that's in all mempools is sufficiently general that if a particular full node wants to support some special application, all they really need to do is whitelist a particular puzzle hash.
Well, correct.
you need a lot of full nodes to support it for propagation to even work.
Well, yeah, that's the thing. If a particular thing does not have one of the puzzle hashes that's whitelisted on a particular full node, it won't propagate it.
I mean, but we can't expect like 60,000 full nodes to manually add every single whitelisted puzzle hash to their list.
Well, having app-specific mempools is the same thing. You have some subset of everything that is okay with a particular format of thing.
I guess my concern there is that by trying to make this too general, you'll end up incorporating some of the logic that would go into drivers or off-chain into that aggregator that goes on-chain.
I think in all of the examples that we just discussed, the on-chain logic is very clear and straightforward, with the caveat that bouncing out to cats and stuff gets complicated, and we need to figure that out.
I mean,
But
there are like thousands of lines of Rust code to implement some of these primitives, so I wouldn't be so sure that it's really simple to do on chain.
Often the on-chain part is really simple, and that's why the off-chain part is complicated. Let's go down the list. For voting, you just add up the votes, right? You need to validate them, and then you add them together. So that's good. For auctions, you look at a particular bid-ask thing, and does it beat the current one? If no, you skip it. If yes, you put it in as the winner, right? For AMMs, when you get into limit stuff, it's more complicated. But for the most basic thing, you just say, okay, well, here's the amount that everyone's dunking in, right? And you just tally that up and you go, okay, well, here's all the amounts coming in and what they wanted it out in. And now you have aggregate values across everything. Here's the old values, here's the new values. And so here's how much everybody's getting out of this transition. And you just give people their payouts.
I guess.
I think that part is straightforward, but it's all the auxiliary coin spends like the cats, the other singletons that have to spend alongside it, the slots.
Yeah, that was my question. I was trying to understand if the puzzle itself is the single aggregator. My understanding was you have to spend all the other coins in the same spend bundle in order to aggregate them, and we can do that today. But it has real scalability limitations.
So my thought is that we just have this rule. Let's say we have this rule that any one transaction that you put into the blockchain can't have more than one aggregatable spend in it, right? So you have a spend bundle. One of those spends, and no more than one of those spends, is an aggregatable thing. And when this gets included into a bigger transaction, the way it always works is that thing had like mini solutions in it. And those mini solutions get glommed onto the end of the aggregated thing. And all other spends in the spend bundle are exactly the same way they were before. They are not changed in any way, shape, or form in the aggregate.
does this assume that everything that's being aggregated is from the same party? Because I think what we were looking for is like everybody is kind of trying to vote independently
Yeah.
for, and then like if they get into the block, their votes counted, and if they don't, they get into the next block. But it's not like
Yeah.
it has to be everything in a spend bundle at once or it fails.
Well, a given spend bundle, like one voter, like that should be in a bundle that is atomically getting in or not, right?
Oh,
Yeah,
Um,
but you need a final. Every vote would need a finalizer, and so you get to a situation where the finalizer is the singleton that can't be spent more than once in one block. The vote is unique. If
have
you
you,
could have everybody put in like a just a partial spend,
so
like if this is just the vote, this is just the action, and then as
if
long
they
as
don't,
there's a single
yeah, I'm not
finalizer,
sure what we mean by finalizer here, but my thought is there's the singleton that's keeping track of the tally, right? And that's the thing that's our bottleneck here, right? So a bunch of people come up with transactions that are individually valid transactions, all of which spend this singleton and increase the tally by one, right? And so the mempool just kind of knows it's okay to allow all these things in. They're not stepping on each other's toes because this one shared coin spend that normally would conflict with that between them is an aggregatable coin spend, right? Then when it comes time to actually make a block, they go and keep all the spends from all these spend bundles other than the one for the singleton exactly as is. Those are completely unchanged, and then they take the singleton and make a spend for it by taking all the individual solutions that were passed in all these individual transactions. And those are all giving like a list of mini solutions to this thing, and it concatenates all of them together into one long list. And that's the new solution for the singleton that's doing the aggregations. And that thing just runs and does its aggregations. And we assume that it's a good puzzle, that because it passed all the individual spends, that the aggregate will always pass, and that's just well behaved that way. And then that does whatever it does, and the whole thing is a valid transaction now. It does result in things like if you're using an AMM, you can't generate your own change coming back. You're sending stuff to the AMM, and then the AMM needs to give you rewards back. So you tell the AMM, here's the puzzle hash I want you to send rewards to.
And we do have a question from YouTube.
Mm-hmm.
Paying to access mempool is kind of good because it
Yeah.
prevents DOS, right?
Yes.
Thank you.
Yes, and there's potential DOS that's bad. So we don't want there to be things where people can well, the biggest one is we don't want people to be able to DOS the mempool, and we don't want people to be able to free ride on the mempools, right? So we don't want people, which kind of wind up being the same thing. We don't want people to be able to introduce a whole lot of transactions into the mempool that push everything out of the mempool, and then suddenly they're all rendered invalid, and the mempool just clears out, and everyone else's stuff didn't make it in. So that's bad, and we don't want that happening.
for the
And
in
we also
the
don't, huh?
in the Ethereum sense, we don't have a way to force people to pay a fee to submit something to the mempool. We only have a way to like hope that their transaction still ends up being included into a block, and then the fee is paid to the farmer.
Well, we do have we kind of have the same thing Ethereum does, because in Ethereum it has this thing where it'll try to run your thing, and then if your thing fails, you still spend something. And we can
Okay.
kind of do the same thing, and that your thing spends, it just might not have any effect. Like it might be that it tried to do a thing and then failed.
We've never done that for anything on chain.
Right. Well, that's because we haven't wanted to do anything fancy. So I'm not sure it's good in Ethereum that if your transaction fails, you only pay a small fraction of what you normally would have paid, because the blockchain still incurs the cost of dealing with your shit. um,
I mean,
I,
there's a bunch of reasons why a transaction could fail, so it seems risky to start charging people to use the mempool.
Well, that's the problem. Like you might have something that failed for good reason or something that is definitely going to fail up front, right? So if someone like makes the trickiest thing here, right, is what if you want a limit order for an AMM, right? That um, so you are going to you need to pay something in order to get your transaction that's the limit order for your AMM propagated through the blockchain, right? Um, and you don't want it to be that you try and pay for this and then it didn't make it in, so you just free rode on the blockchain, just propagating your transaction around that didn't make it in.
Well, the logic we have right now is that someone has to pay more than you if they want to get your transaction evicted.
Well, that's the thing. You are paying more than others to evict their transactions, but then when the time came to make a block, suddenly your transaction wasn't valid anymore. And and so you didn't actually have to pay that.
I think that comes down to the decision of which puzzles we should whitelist to allow aggregation. Because if you validate that it's impossible to run into that state with a given puzzle, then you can aggregate it.
Yeah, no, we should have whitelisting here or some reasonable thing on it. But here's a very specific example of something that we might want to whitelist that is an issue, right? Someone puts in a limit order to an AMM, right? And it didn't make it. It did not make the limit. What are we supposed to do here, right? Because we don't want to get into the business of guessing how close this is to the limit to make it whether it's worth it propagating, right? We kind of want to propagate things even that are pretty far out of the limit, right? So it would be good to just like propagate these things around that are off the limit and you're just still having to pay transaction fees on them, right? So that you send your thing to the AMM and the AMM goes and figures out the prices and whatever everyone's going to get and goes, well, here are people who didn't make it in, right? Here's people who were out of the limit. And so rather than giving them what they asked for, like what they asked for back, I'm just going to send them their money back. I'm just going to give them back exactly what they sent to me in the same currency as they sent it to
So
me.
you're saying that if in a given time window, if a transaction is outside of the range of the price, the puzzle would still allow it to be included into a spend, and it would just
Yeah.
take a fee to the farmer or whatever.
Yeah.
Well, thank you all. We are getting close to the top of the hour. I'd like to just remind everybody, if you do have questions, please use the Zoom Q&A, ask them on YouTube, or feel free to jump into our Discord and the community feedback channel. We don't expect a solution by the end of this call, but if people are interested in the discussion, want to engage more within it, not only are we going to post this video on YouTube, you can also jump into our Discord and continue the discussion there. So that all being said, I'm going to turn it back to you guys and let the conversation keep going.
I don't see anything wrong with the current proposal or the apps I can think of.
What do
I
you mean by
guess
the current proposal?
the one where you try to aggregate
Oh, okay.
spend.
Okay, what I'm saying.
Yes.
Yeah.
I guess my other argument is that the way I'm thinking also about privatizing the mempool with
Yeah.
maybe custom mempools
Yeah.
is that currently it takes a spend bundle about 1 to 3 seconds
Yeah.
to propagate, and
Yeah.
that will become a limiting factor once you take kind of the replace by fee growing big. So you're still limited to say one transaction per singleton per second.
I'm not sure what you mean. Like yeah, like the semantics of having a private mempool, I think is mostly a permissioning thing. That you have a transaction and something will propagate it, right? And so there's some things that'll propagate it and some things that won't. Um, and so if you have a private mempool or something, that's just this area that will propagate it more. So I guess there's two things here. There's permissioning and then there's connectivity, right? That you can say, well, here is a some set of the broader set of full nodes will actually just happily propagate uh, like these particular types of aggregatable transactions. Actually, come to think of it, oh, you know what? Oh, actually, it's not problematic because with the approach that I'm talking about, the individual. Oh, here's the issue. Okay, here's what happens. The With the broader mempool that does not support aggregation to these particular transactions, right? It will propagate them. The problem is as far as it's concerned, they conflict with each other, right? So it won't, it'll let in one of them, but it won't let in multiple ones. And if a block happens to be made by one of the ones that just doesn't support this particular kind of aggregation, only one of the transactions will get through. But you can have a thing where there's some set of the mempool that does support these, and you want two things to happen. You want them first off to allow these through, but second off, you want good connectivity between them so that they're like not just random things floating out there, but they tend to be more connected to each other so that they know to propagate these things to each other. Although now I'm talking about it, it's like there's an awful lot of incentive for basically everyone to very aggressively support as many different transaction types as they possibly can because it's free money, right? Like you want to do that. Especially like I could totally see a thing where we have AMMs that are using the mempool and we just have a non-trivial amount of transactions that are just bid asks not making it through in the normal course of business in the mempool. And it's just like a really normal thing that happens. Yeah, which if we're not it's like really nice that there's an awful lot of full nodes making blocks for themselves. And I do worry a bit that if we get like way too many, if it becomes difficult to have a reasonable list of types of transactions that you support, there's going to be way more outsourcing than we would really like of farmers not making blocks themselves and just outsourcing that to one of like the two services that actually do it, which we don't want to have happen. Um, uh, it, I think this shouldn't be too much of a problem if we make it so that it's really just a matter of having like a whitelist of particular transaction types and there's only like 20 of them that anyone cares about. This is not terribly problematic. But there definitely could be a situation where there's some lesser transaction type that's supported by some fraction of everybody, either because it's very, very new or controversial. Some fraction of things don't want to support it. And you might want, particularly if the issue is just that it's new, you might want to have sort of an overlay mempool that supports extra connectivity specifically within full nodes that support that particular thing so that those transactions can actually get propagated.
Yeah, thank you. We do have a question in Discord, a couple of follow-up questions to it as well, but I'm going to start with the first one. If you try to aggregate, what happens if the aggregation is more than what can fit in a block?
That probably, there's going to be some delta here, which is part of why you need to only allow well-behaved puzzles to do aggregations. But generally speaking, what's going to happen is you have these individual transactions that spend the aggregatable coin. And for the most part, what's going to happen is each of those is going to have some cost, but the combined cost, the sum cost of adding those together into a single aggregated spend will actually be less than the individual costs of any of them by themselves. Because just because that's the way just things tend to work just in general. And even if it costs a little bit more, it won't be that much more. So by dint of these individual transactions having made it into the mempool, it will be okay to let them in, right? If there's just too many of them, they get forced out because they don't have enough fees on their own merits individually. It does result in a little bit of potential headache and slop because there is potential headaches with maybe actually when you aggregate them, it increases the costs and that can be bad for logic. So that could be annoying. And then on the other direction, it could be that their combined costs are lower. So when you're making a block out of it, you might go, oh, wait, I actually have some extra headroom and you want to add a few more transactions at the end. But for the most part, it should be the case that as long as only well-behaved transactions are allowed to act as aggregatable, normal blockchain logic works. Although I do think it's probably a really good idea to have the rule that any one transaction can only have a single aggregatable spend in it.
Perfect. Thank you. And a follow-up question on that is focused on how these things are going to be aggregated. If the aggregation and the spend requires that particular coin ID and a spend did not make it into that particular block, is that spend then rejected for the next block, or would there be potential for it to rebase itself on the latest singleton?
That is a good question. Um,
With the action layer, they should be able to continue on to the next coin spin.
uh, well, they certainly could. Like whoever introduced the thing could definitely rebase it themselves and up it. It's the question of does the mempool automatically rebase it up?
Well, I think it should. Otherwise, you could submit a bunch of transactions that will never be confirmed. You want them to
Um,
eventually be submitted unless someone.
oh yeah, yeah, actually, yeah, you as a matter of policy, you want it to as a matter of policy, you want it to be that they kind of have to go up, right? It should stay in the mempool by default. That should be the normal behavior so that you don't introduce transactions that you're not going to have to pay for. We already have potential for that because you can just introduce transactions that have a not valid after of the current block
Yeah,
height, and we do something for that. I forget
we
what,
we have like a limited submem pool that's only a block large.
yeah. But as a matter of policy, you want rebasability to be the default. So that's something we should keep in mind that we should try to support that as much as possible or require it as much as possible.
Yeah, much appreciated. Definitely answers the question in that regard. We are near the top of the hour, so I'm going to turn it back to you guys for any last minute thoughts on this topic. And again, we're not expecting a solution to come out of it, just a great way to hear the big brains talking about a tough problem.
I would be curious if anyone thinks there would be next steps. For example, I think that for now, the advice for decentralized apps would be try to be compatible with replaced by fee. And this new mechanism seems like it's most likely going to be compatible with whatever replaced by fee is using and then more.
I think we have, of the four use cases we discussed, there's sort of two easy ones and two hard ones, right? So the two easy ones are our votes, our vote counting, and auctions. And so what we should, it makes sense for us to generally plan as a vague plan to try and come up with something that supports those two without supporting the others. Because the others have a lot more headaches in them. Particularly around having cats that the mempool needs to aggregate together at the end and having a communication to an auxiliary thing because it needs to do the cat's end and wanting to have limit orders and blah, 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 blah. Yeah. So, but the vote, oh, sorry, no, actually auctions is one of the hard ones. The easy ones are, voting and relay. Relay is pretty easy. Because those don't involve anything weird at all. Those, like the only thing that you want to change when the aggregation happens is very specifically what just the aggregate coin does and its behavior. So yeah, so we can I would as a vague plan I would like to try to figure out something which works for those with sort of a view to what we might add in the future to supporting the others. Um, that's my thought. I need to sleep on all of this a lot.
Oh, that's great. I really appreciate everybody taking their time today to sit down, discuss this tough problem of mempool parallelism. And thank you to the community who asked some excellent probing questions. Again, this will be posted on YouTube after we've had some time to clean up the video and audio. So expect that at some point next week. And if you want to further discussion with the teams, feel free to jump into Discord or reach us on the other channels that you can. But thank you all for your time today and hope you all have a wonderful one.
Bye, everybody.